Hello, I welcome you all in this course on refrigeration and air conditioning. Refrigeration part we have already covered in the previous lectures. Today we will take up introduction to air conditioning. Now in refrigeration, the temperature is controlled at a certain level, but in case of air conditioning, not only temperature, humidity is also controlled. Temperature, humidity. In addition to these two, the quality of the air is also controlled in air conditioning. So air conditioning is not only about controlling temperature and humidity, it also involves the controlling the quality of the air. It is possible that you are sitting in a room, temperature is ideal temperature. In India, the ideal temperature is 25 degrees centigrade, humidity is 50%, this is the ideal case, but you may not feel comfortable. You may not feel comfortable because the quality of the air in this room is poor. The quality of the air includes everything, the dust particles in the air or cleanliness of the air. Second is presence of carbon dioxide in the air, because if there is a high level of carbon dioxide, then there are symptoms like you will start feeling headache or body pain and you will not feel comfortable at all. So it has been witnessed, especially in the classrooms which are air conditioned or the computer centers where the population density is high, the level of the carbon dioxide shoots up, and this shooting up of level of carbon dioxide causes the state of discomfort among the occupants. It happens like this: you are sitting in an air conditioned environment, temperature is 25 degree, you are not feeling comfortable, but when you go outside temperature may be 40 degrees centigrade, but you feel very fresh. That is due to excess of carbon dioxide in the closed environment. So air conditioning, I am repeating, air conditioning involves not only control of temperature, humidity, but also quality of vapor. Now as in the case of refrigeration, if you remember, we express in terms of tons of cooling. In air conditioning also, we express the capacity of the system in the forms of tons of cooling, tons of refrigeration or tons of cooling. And again I like to repeat here, because I have already told you in the first lecture that there are two tons, one is TON, another is TONE, double NE. This TO double NE is 1000 kgs. Now this ton, it is UK ton and US ton. Now UK ton is 1016 kg, this is 2000 kg, and this is 2000 pounds, and these 2000 pounds, when it is converted to kgs, it comes around 907.185 kgs. And when we talk about 1 ton of cooling, the cooling it involves this ton. So 1 ton of cooling means the conversion of 1 ton of water available at 32 degree Fahrenheit into 1 ton of ice at 32 degree Fahrenheit within 24 hours. So that heat removal rate is known as 1 ton of cooling, and I have told you earlier also that 1 ton of cooling is equivalent to 12,000 British thermal unit per hour, and which is 1 ton of cooling is 211 kilojoules per minute or approximately 3.5 kilowatt. So wherever a cooling of the order of 3.5 kilowatt is provided, we say that the cooling is of the order of 1 ton of cooling. As a mechanical engineer, you should be very conversant with the units. For example, volumetric flow rate. In volumetric flow rate in SI system is expressed in terms of meter cube per second. However, you will find in most of the cases in air conditioning, the volumetric flow rate is expressed in inch pound system, and that is CFM. CFM stands for cubic feet per minute. Cubic feet per minute. Now, if you convert this CFM into the liters per minute, it turns out to be 1 CFM is equal to 28.317 liters per minute. Because we are conversant with the SI units, but in you will find in number of the books on air conditioning also they are using mixed units, they are using mixture of IP and SI units. But here in this course we will be covering only SI units. So, we will convert all the IP units into SI units. So, we have to be very conversant with the conversions. So, cubic feet per minute shall be 28.317 liters per minute, which will turn out to be 0.47195 liters per second. So, if I say half 100 CFM, 100 CFM will turn out to be around 47 liters per second. So, it is almost half. Normally, you will find in air conditioners when we design ACs for the large building, certain minimum flow rate has to be maintained. And a thumb rule is for 1 ton of cooling, it has to be around 400 CFM. But normally, you will find in the split ACs split ACs or the window type of ACs, the CFM is lower than this. It is kept lower than this because it is used for the confined space. Otherwise, for the large system, normally the CFM is 400 CFM per ton of cooling. So, immediately we can take, even if you take 100 CMF is equal to 50 liters per second, that will also do. But normally we assume that 100 CFM is equal to 47 liters per second. In some of the cases, CFM is also expressed in meter cube per hour, and 1 CFM is 1.7 meter cube per hour. Sometimes area is given in feet square. In air conditioning also you will find that area is given in feet square or area is given in square yards. In this case, if you want to convert square feet into the meter square, then square feet divided by 10.764. These conversion factors you have to remember. Area in square feet divided by 10.764 will give you area in meter square. Distance, perhaps all of you may be knowing that 1 mile is equal to 1.61 kilometer, and 1 nautical mile is equal to 1.15 mile. Likewise, there are many conversion factors, like if I take 1 gallon of UK, that is equal to 4.546 liters. If I take 1 gallon of US, it turns out to be 3.785 liters. Likewise, you will have to convert by yourself the velocity in fits per minute to meters per second. This you can do by yourself. You don't need my help. Here, this fits per minute you can always convert into the meter per second. So, mechanical engineer, you have to be very conversant with the units, especially in air conditioning, because in air conditioning books, in some of the books I have found that they are using mixed units, right? And here we will be following only SI system of measurement. Now, efficiency of air conditioner. Now, in a refrigeration system, we were using COP, coefficient of performance. Coefficient of performance was refrigerating effect divided by energy spent for this refrigerating effect, that is energy consumed by the compressor. The same COP is used for air conditioner also. Every air conditioner has certain COP. Now, in air conditioner, normally COP is higher than the refrigeration system. The reason being, if you look at the pH diagram, in refrigerating system, the evaporator temperature we are assuming around minus 20 degree centigrade and condenser around 40 degree centigrade, right. Condenser temperature can be higher than this, it can go up to 50 degree centigrade because if the heat is dissipated to the surroundings. Anyway, here the evaporator temperature is minus 20 degree centigrade, condenser temperature is 40 degree centigrade. But in air conditioning system, in most of the cases for residential air conditioning, we have to maintain 25 degree centigrade temperature of the room. For that purpose, the air coming from the air conditioner may be of 13 or 14 degree centigrade. In that case, this temperature shall not remain minus 20 degree centigrade, it may be around 0 degree centigrade or 1 or 2 or 3 degree centigrade. In that case, you can see here there is more refrigerating effect and less power consumption. That is why the COP of air conditioning system is often or in most of the cases is higher than a refrigerating system. It is a general conclusion. Now, efficiency of a air conditioning system is not expressed in terms of COP. If you go to the market and purchase AC for yourself, you will never find this COP on the data sheet. Now, in air conditioning system, the efficiency is expressed by energy efficiency ratio. Energy efficiency ratio is nothing but a ratio of heat transfer in BTU per hour and energy consumed in watts. Now, here itself you can see that there is a mixed unit. BTU per hour is energy transfer rate in inch pond system and W is the heat transfer rate in SI system. Now, here we will convert this in inch pond system unit into equivalent of SI system unit. Now, British thermal unit, that is BTU, is equal to 1055 joules. Now, if I write BTU per hour, that turns out to be 1055 divided by 3600 joules per second, or this joules per second is nothing but watts. So, in denominator and numerator we will have same type of unit. Now, here BTU per hour can be calculated as 1055 divided by 3600, that turns to be 0.029, 0293. So, we can comfortably write that COP is equal to 0.293 energy efficiency ratio multiplied by 0 energy efficiency ratio. So, if we have energy efficiency ratio of any equipment, it can be easily converted into the COP. For example, if an AC available in the market has energy efficiency ratio of 10.5. So, if I want to convert this into the COP, it is going to be equal to 3 into 0.293 is equal to 3.08. So, this is the conversion of EER into the COP. In the air conditioning market, you will find that there is a star rating of AC systems, 1 star, 2 star, 3 star, 2 star, not 1 star, there is 2 star, 3 star, 4 star and 5 star. Now, 5 star AC, the 5 star AC should have COP greater than 3.5. There are a few manufacturers in the market who give 5 star AC. 4 star should have COP greater than 3.1 and definitely less than, sorry, greater than 3.3 and less than 3.5. So, in this range it is going to be 4 star or greater than or equal to. Similarly, for 3 star AC, the COP has to be greater than or equal to 3.1 and it is to be less than 3.3. And I do not recommend that when you purchase for AC for yourself, you should go below 3 star. It is always recommended that one should go for a 5 star AC. It is energy efficient and though they are slightly costlier, but break-in point comes very fast. So, ultimately you remain in the profit zone when you purchase a 5 star AC. Their fixed cost is high, but their running cost is low. They consume less energy. Now, if you go down star wise 5 star to 4 star to 3 star, the fixed cost may reduce, but the running cost will increase. So, at the end of the life of the AC, normally it is assumed that the life of an air conditioner is 15 years. It goes up to 20 years also, but average life is considered to be 15 years. So, in a 15 years time, this is always a profitable buy. This is not a profitable buy for the span of 15 years. Now, after this star rating, this is about the heat transfer, but air conditioning involves not only heat transfer or maintaining the temperature, it also involves the movement of air. Movement of air in this room. The movement of air in a residential building should be such that in any part, suppose this is a room, so any part of the room the temperature difference should not be more than 1 degree centigrade, or if it is a 4 room or 3 room or 4 room set, the temperature difference should not be more than 2 degree centigrade. So, air movement in the building is very important, right? With the right kind of air movement, you can maintain higher temperature of air conditioner, and when you are maintaining high temperature of air conditioner, a lot of energy can be saved. So, for the air movement, first of all we should ensure that the air velocity in the system, air conditioning system, should remain between 0.1 to 0.3 meters per second. Especially in the summers, it is recommended that a velocity should remain in the range of 0.1 to 0.2 meter per second. In winters, where air conditioner is used as a heat pump, in market also some of the air conditioners are available. These air conditioners you can use as heat pump. So, in the summer season, they can be used as a heating device, and because when the cycle is reversed and air conditioner is used as a heating device, its efficiency is COP plus 1. So, suppose I want 1000 kilowatt of heating, 1000 watt of heating, right, and I use reverse cycle. So, 1000 watt, suppose COP of the system is 3. So, 1000 watt divided by COP will give me the power consumed, that is equal to 1000 divided by 4, and that is 3 plus 1 4, and that is 250 watts. So, by spending only it appears to be strange, and it appears to be the violation of law of conservation of energy, because at the expenditure of 250 watts, we are getting heating equivalent to 1000 watts. If same type of heating has to be done with the electrical heater, I will be spending, I will be paying for, in 1 hour run for this, 1 kilowatt hour. 1 kilowatt hour. So, if I run a electric resistance heater for a period of 1 hour, the unit of power energy consumed is 1 kilowatt hour. If I use reverse cycle type of or if I use a heat pump, where heat is pumped from lower temperature, outside lower temperature to inside higher temperature, in that case the power consumed only 250 watt or 1 by 4 kilowatt hour. There is straightway saving of 75%, and you can save a lot of money on electrical bills. that is why it is always recommended. So, for the heating purpose, one should go for heat pump type of heating instead of any resistance heating, electrical resistance heating. Further, location of air conditioner in a room is also important. Now, cold air, in summer, a cold air has to come into the room. So, cold air should strike upper half of the body of an individual, only then it will give a state of comfort. Same way, in winter heating, the hot air should strike the legs. If hot air is striking the legs, it will give very good state of comfort instead of the fact when it is striking upper half of the body. So, cold air in summers should strike upper half of the body of the occupants, and hot air in the winters should strike. Provisions should be made that the hot air strikes the lower half of the body. Sometimes it is not possible because you have only one air conditioner and it works as a heat pump in winters and in a cooling device in the summers. It is not possible, but if it is possible, then such arrangements should be made. Now, there are number of application of air conditioning system. Not only for comfort application, it has got immense industrial application also. For comfort applications, the ACs are used in the residences, as all of us know. Retail facilities, if you go to the market, you will find that in the number of the shops, they are using air conditioners. Commercial and public buildings, hotel and restaurants. Now, most of the restaurants are air conditioned, hotels are also, rooms in the hotels are also air conditioned. Educational facilities, now schools and the colleges, part of the schools and colleges, they are also put under controlled environment or under air conditioners. Healthcare facilities, hospitals, nowadays hospitals are also air conditioned. So, it has got wide application. So, it is not confined to the residential cooling. The air conditioning system, even the automobiles, train, aircrafts, ships. In addition to these comfort applications, there are industrial applications also for air conditioning, and there is a huge industrial application like engine. I am quoting some of the facilities like engine test facility, laboratories, most of the laboratories are air conditioned, data processing and telecommunication, textile industries, printing plants, museum and libraries. There is special kind of air conditioning is required in the industries. For example, museum and libraries, the airflow should not be very high, right. Fresh air has to be maintained inside the museums. Environment control for animal and plants, power plants, nuclear facilities, even in the mines the air conditioning is done, and there are many more hundreds and thousands of applications. So, the control environment has become way of life nowadays, and definitely when we work in a control environment or air conditioned environment, our efficiency and grasping power increases. And it has been also noticed that when a classroom is air conditioned, the students are more alert and attentive, and their grasping power also increases. And conclude the introduction of air conditioner here. In the next class, we will start with the properties of moist air. Thank you.